Hi there. Earlier we learned about object constructors. We wrote a function and used this to define key value pairs. We learned about using an object prototype to define functions and methods for the object. To create an instance of our person object, we used the new keyword. We would then be able to access all of the object's properties and methods in other parts of our code. Let's look at the factory function. The factory function pattern is similar. We're defining a function, we're taking parameters. In this case, we have a statement to return our properties and methods, but instead of using new to create an object, we set up and return a new object by calling the function. So here I've created the variable Jeff, and I'm calling the person factory function. I'm feeding it the name and age parameters. And so when I run this, I see in the console that I'm able to return Jeff's name property. I'm also able to call the say hello function to log hello to the console. Cool. Inside our factory function, this return statement is using a shorthand that wouldn't have been possible before 2015. Back then, our statement would have looked like this. We would have a key and a value pair for each property. This is a bit repetitive, no? Well, if you're referring to a variable that has the same name as the object property, like we do here, you'll actually be able to condense it like so. Sweet. With that in mind, let's consider the following code. Here we've defined 4 different properties: name, color, number, and food. How might we log these values to the console in a manner that's easy to read? Why don't you pause the screencast and try it yourself? When you're done, you can check back here and we'll do it together. I wonder how you did it. Well, there are a few different ways we could log these values to the console. We can log each item individually. When we run this, we're logging all the values to the console, but this is a bit repetitive and it's not clear there's a connection between the values. Another way to do this is to use one console log statement and put all the values inside the parentheses separated by commas. Now we're logging all 4 values on the same line, but it's still a bit disorganized. What if we wrap all of these values in curly braces like we did before with our return statement? Now when we run this, we see key value pairs all within our curly braces as an object, and the information becomes more meaningful. Awesome. Okay, now we have a good foundation for using factory functions in our code. But first, let's talk about closure. Well, actually, let's roll it back and check that you have a good grasp of scope in JavaScript. Remember, scope determines where variables and functions can be used in your code. Consider this. Here we've defined a variable, we've declared a function, we've called the function, and then we want to log A to the console. Which value do you think will be logged to the console? Do you have a guess? Let's run this and see. It's 17. Can you edit this code to print 99 instead? Pause and give that a try, and then we'll take a look at what's happening. So this is what we know to be scope. Our first declaration of A has global scope. We can access this value anywhere in our code. The second declaration of A has local scope, and we can only access that value if we return it from the function. Got that? Let's look at another example. Here we have a factory function. Within that factory function, we define 2 other functions, capitalized string and print string. We are creating an object by calling the factory function and feeding it the string taco as a parameter. What do you expect to be returned from these functions? Why don't you pause and put your guess in a code comment under each function call, then hit run and see if you return the results you expected. All right, let's look at these one at a time. Because of the concept of scope, these functions inside a factory function can't be accessed outside the function itself. So 1, 2, and 3 fail. We get messages that the functions are not defined. Why are we able to print our string in the last call? Right, because we returned print string from our factory function. But how did our string get to be uppercase? We can't access capitalized string outside of our factory function. Oh, but print string can, and we're returning print string from our factory function. This is closure. Let's think about this. Closure means that functions retain their scope, even if they are passed around and called outside of that scope. In our example, print string has access to everything inside a factory function, even if it gets called outside of that function. Right on. Let's look at yet another example to make sure we've got this. Here we have counter creator. Counter creator initializes a local variable, count, and returns a function. To use this function, we have to assign it to a variable. Here we've done so. Now, every time we run the function, it logs count to the console and increments it. Check it out. Notice that counter is calling the return value of counter creator. The function counter is closure. It has access to the variable count and can print and increment it. Otherwise, our program has no access to that variable. So, in the context of factory functions, closures essentially allow us to create private variables and functions. This allows us to separate concerns and makes our code cleaner and easier to read. We only need to export the functions the rest of the program is going to use. So if we look back at our print string example, in this case, capitalized string is a private function. And since we're returning print string is public. Okay. The concept of private functions is very useful because making supporting functions inaccessible makes the code easier to refactor, easier to test, and easier to understand how to use objects in your code. Let's zoom back out to factory functions. You can pause and take a minute to read through and figure out what this code's doing. All right, what happens if we call Jimmy.die? What about adding or taking away from health? Well, since neither health nor die are exposed publicly, we're going to get an error in the console. This is actually a good thing. Setting objects up this way makes them easier to use because we've encapsulated it and can only access it by exporting a function. When we learned about constructors, we looked into the concept of prototype and inheritance, meaning giving our objects access to the methods and properties of another object. How can we do this using factory functions? Let's take a look. Here we have the original object person. We are creating an object called nerd that is built on the person prototype, and we're returning say name and do something nerdy. So when we create our function by calling nerd, we can access the methods we defined in the factory function. But the cool thing is we can be selective with what functions to include in our new object. We can use some of the functions or all of them. With object assign, this is easy. Object assign will copy all the properties from one or more source objects to a target object and return the modified target object. Let's look at one other thing, actually similar to factory functions, modules. The concept is the same as the factory function, but instead of creating a factory to use over and over, the module pattern will actually wrap the factory in an immediately invoked function expression. See these parentheses here at the end of our closing brackets? This means the function is immediately called. In this example, the function inside the IIFE is a simple factory function, but we can assign the object to a variable, calculator, since we don't need lots of calculators, just one. And as before, we can have private functions and variables, keeping them tucked away in our module and choose which ones we want to expose for use in the program. An excellent benefit of encapsulating the inner workings of our programs and objects is namespacing. This technique is used to avoid naming collisions in our programs. For example, we might have a function to add items. In one place, we might want to add numeric values. In others, we might want to add items to our HTML display. If we've encapsulated everything, we can chain this same method to different elements within it. All right, we've covered a lot of ground. Factory functions, scope, closures, private variables and functions, modules, and namespacing. Feel free to watch this again and pause to play around with the code to better your understanding.